Hi, I'm Steve Salamone with Pioneer Metal Finishing, giving you a tour of our New Hope facility in New Hope, Minnesota. At Pioneer, we measure our KPIs on a daily basis. We use a safety, quality, on-time delivery, productivity, daily labor, and our loads per day. At Pioneer, it's really important that we stay ahead of the environmental controls. You may realize as you're walking in this building, you don't get a lot of heavy chemical smell in the building. That's because of the air makeup we have in the facility. The air makeup moves this air around more than you move it around in your own home. We also have an extensive waste treatment system. This waste treatment system allows us to reduce the usage of water that we have. We moved here 3 years ago. We were using about 250,000 gallons of water a day in our facility over on River Road. This facility we use anywhere between 80 and 100,000 a day. When we're racking up parts, we can use one of two items. We can either use titanium tooling or aluminum tooling. If we use titanium tooling, the tooling will virtually last forever. If we use aluminum tooling, it anodizes along with the parts and needs to be stripped before we can use it again. We make electrical contact through the work bar, into the tooling, and then actually into the parts. We need to make rigid contact with the parts to make the contact points, and then the anodizing occurs.
What is anodizing? Using chemistry and electricity to convert aluminum to aluminum oxide, resulting in a durable, application-specific coating. Racked parts to be coated are anodes when subjected to a direct electrical current in an acidic solution. This is how the anodizing process was named. Racked parts are conveyed through Pioneer's automated production line containing numerous tanks of unique solutions. Each load of parts follows a unique recipe of steps, often involving submersion in multiple different tanks. The specific solutions and type of aluminum impacts aesthetic and physical properties possible in anodizing.
The parts get dipped into a sulfuric acid bath. That sulfuric acid bath builds an oxide layer on the parts. That oxide layer is very durable. It allows us to dye the parts if we want them different colors, and it provides other aesthetic benefits. This is a schematic of our line. Our customers' parts will start here at the beginning. They'll go through several different steps of pre-treatment. From there, they work their way on down to the anodizing process. The anodizing process back around to the dyeing and sealing process, and then they'll be complete at the end and work their way back out to be unwrapped. What you see here is a recipe. A lot of times our customers have a feeling that, the parts go through 1 or 2 different tanks and they're done. They could go through 30 or 40 or 50 different tanks before they're actually completed. One of the other things we have with this automated line is we have complete traceability from a quality standpoint. James, can you bring up that? So I have the ability to look back at the entire process from start to finish and make sure they follow the specific process we set up for those parts. This will show you right here what that process was, and I'll be able to look back and make sure that the customer's parts went through each process step, and I can verify within seconds of what they had for that process. That's really important for us from a quality standpoint. That allows us to troubleshoot and fix and develop a corrective action that's effective long term. This is an example of where we rack up multiple parts in one way, and then as she's done, it'll expand out and rack the parts up to maintain efficiency and consistent racking methods. As you can see here, here's the entire rack with all those parts that she's racking up.
Steve, can you tell us a little bit about why racking design is important?
Yeah, a couple of reasons. One, we want to be as efficient as possible to make sure we provide competitive pricing. So we want to maximize our load size, not only from an efficiency standpoint, but from a quality standpoint. When we're able to run higher, volumes that are consistent on each and every order, we're able to maintain a tighter tolerance in coating thickness. From a quality standpoint, Pioneer Metal Finishing wants to make sure that we provide the customer with the best possible quality. We meet their specifications, we meet their delivery requirements, and we provide a level of confidence that while their parts are here, they're handled well. So at the end of the process, we'll do a visual appearance of the parts, verify they meet the color ranges with that's been established with the customer. We do coating thickness checks according to the AQL and anything else that a customer may specify specifically for their product.
So Steve, how would we specifically verify the thickness coating of thickness post running these parts?
Great question, Corey. One of the things we do is we use eddy current testers. So if you want to get a shot here, here's what we do. We'll measure the coating thickness by doing this test. We take 5 readings on a part, take the average of the coating thickness, and validate it meets the specification that's required. This is our masking and dry film area. We do tape masking and dry film. We also do a paint mask when it's highly precision, and then we do plug masking. As we move on here, I'm going to also show you a laser masking operation we have on the outside of this room. We also have a laser capability that we've added into Pioneer. The laser was added for 2 reasons. One, to provide customers with laser capabilities that kind of enhances their product that's already been anodized or plated. We've also added it as a masking option where we can laser to provide continuity or precise looking masking. You may look here at some of the stuff that we laser. This shows some of the decorative stuff that we're doing. And then this shows an application where we are doing a laser masking for continuity. We have fixtures in the process. Almost all parts that are lasered need custom fixtures. So sometimes we need to create that internally.
Steve, how are the laser fixtures designed and manufactured? And I understand that's a big part of the process. Precision, consistency.
Good question, Corey. We are able to do a 3D development of the laser fixture that we want. As long as we have a print from the customer's part, we can develop a 3D replica for us to create a fixture that we can use in the laser process. As we get your information, we'll develop the fixtures to validate it, and then if we need to have further custom tooling, we can establish that. Also down the way here, we have our chemistry department. Our chemistry department monitors our chemical titrations, our tanks. They verify the chemicals that are needed to be added to the tanks to ensure that our quality meets our customer specifications. That's done on a daily, hourly, weekly basis. They'll do different checks depending on what the recommended requirements are of the manufacturer.